Right. Right. Okay, now this is new lesson. According to our syllabus, this is second lesson. It is called function, right? In pure mathematics, you should have a good knowledge about function, because in under pure mathematics, many of lessons are under function topic, right? So we have to study here six function basically. After that, another 4 lessons we have to study this topic, but that 4 functions comes under lessons, right? One is logarithm function and exponential function, trigonometry function, like that. Polynomial function, rational function, those are lessons, right? Under functions, there are initially we discussed about basic 6 functions here, right? Right. Before go to the functions, we should have idea about relations. We should have idea about relation. In here, relation mean there is a set. Earlier, this is the set notation, right? Then we have to write down elements of this set like this. Okay, this is earlier notation, right? Then there is another set. That set also elements. No? Now there are 2 sets, right? Then relation mean first set. This is the first set. No? This first set elements are with connection with second set's elements, right? We have to denote in if this element is connection with this one, we have to put arrow from this element to this element, right? Then we have to put arrowhead. Then if this element is connection with this element, then we have to draw a straight line and put here arrow mark, right? This element, if connection with this one, we have to put like that arrow. Okay. Now what you can see here, first set all the elements, no? First set all the elements are connected with second set elements. No? But in second set, there are few elements, this one and this one, right? This element and this element. These 2 elements in second set with no connection, first set element, no? It can be there, it is okay, right? But first set, all the elements should be connected with second set element, right? Then if we check this connection, that means what is the reason this element connected with this element, right? Then it should be same with this element connection with this one also, right? Okay. Here connection means some mathematical operations, right? Mathematical operation mean basically we study about four mathematical operations, no? One is addition, second one subtraction, multiplication and division. Okay. Under mathematical operations, this element is connected with this element, then same connection, then same mathematical operation for this element to connected with this element also, right? For example, let's think this element is 2, then this, if this element 4, then this element connected with this element by adding 2, right? If we add 2 to 2, then what is the result? 4, no? Then this element 3, then this element should be 5. Why? If we add 2 to 3, then what is the answer? 5, no? That is the same mathematical operation, right? Then there is a relationship between first set and second set, right? Okay. Then there are two types of mathematical relations we have to study. One is one-to-one relation. One-to-one relation mean this is the first set element, right? So these are the second set elements, right? First set one element connected with second set one element only, right? And if we check second set any element, it is connected with first set one element only, right? This is the way we have to check in. If we check this element, from this element there is one arrow, no? This element also one arrow, this element also one arrow, this element also one arrow, this one also one arrow. That means this element connected with second set only one element, right? Then if we check this element connected with only this element. This element connected with only this element, right? So there are one-to-one relation, this one, right? First set one element connected with second set one element only, second set one element connected with first set one element only, right? Later we name this one-to-one function, right? This is called one-to-one function. Then the meaning of this one-to-one relation is function, right? Then there are second relationship. It is called many-to-one. Many-to-one, right? Many-to-one relation mean many-to-one relation mean this is first set and this is second set, right? These are the first set elements. These are the second set element, right? Now, first set few elements. First set not only one, first set few elements. That means this element, let's think this element connected with this element, right? Not only this element also connected with this element, right? Right. Then what is the meaning of that? First set many element connected with second set one element. That is a name many to one, right? Okay. second set one element, first set many element. Right? Otherwise, if we check it this way, one to many, no? If we get second set one element, it is connected with first element, first set many element. Right? How this can happen? This is always happen. We have to take a mathematical operation, not just like adding, subtract, multiplication, division like that. Right? This is happened due to if we square this one, right? If we square it, if this is 2, then what is the square of 2? 4, no? Then this is minus 2. Minus 2 square also 4, no? Then this one positive 2, this one negative 2, here positive 4. Right? Then this one minus 1, this one positive 1, then minus 1 square means positive 1. No? If this element positive 1, then this one connected with this one, and this element also connected with this one, right? And if this element is 5, then what is the square root of 5? 25. If they are listing this one 25, then this element is connected with this one, right? There, meanwhile, there can be one-to-one connection also, right? So this is called many-to-one relation, many-to-one. Then one-to-one relation and many-to-one relations are functions, right? Then there are another two relations in mathematics, but we don't study these relations in A level maths. Other one is one to many. One to many. Now you can get an idea about what is that, no? One to many. That means first set one element connected with second set many element. Right? Both on many to many. Many to many. Then what is the meaning of this one? First set many element connected with second set many element. Second set many element connected with first set many element. Right? So these are called relations. Right? Then first we have to idea about what is relation. Then there are two types of relations, one-to-one relation and many-to-many, many-to-one relation. After that we can go to the definition of function, then type of functions, right? Okay. First we have write down lesson name, no? Function. Under this topic, write down relation. Relations. Relations. Right. Now you can write down a rule which corresponds, write down, but this is the node for relation, right? A rule which corresponds to elements of one set, to elements of one set, to elements of one set onto the elements of another set. Elements of another set is called a relation. Is called a relation. Right, write down as a new paragraph. There are four relations. There are four relations in mathematics. there are four relations in mathematics. Under this lesson, we have to study two relations. Okay. Now write down first one-to-one relation. One-to-one relation. One-to-one relation. Then draw like just like this figure. Draw a figure just like this one. Right. Now write down this say. Okay. Now write down this say. Here one element of first set. Here one element of first set is related to only one element of second set. Only one element of second set. And second set one element related to only one element of first set. Okay, right. Now second relation, many to one relation. Right. Now draw a figure just like this. Right. Now write down this say. Here many elements of set 1. Related to one element of second set. And second set one element and second set one element, related to first set many elements. Right. Okay, now we can go to the definition of function, right? Now we know what is the relation, no? Then we have to know what is function, right? What is function? Definition of a function, right? Normally there are 6 definitions for functions, right? Then that means there are 6 mathematicians give definitions for what is function, right? In A-level mathematics we have to study the first definition for function, right? So here we don't want to know what is the name of that mathematician, because here we study only one definition. If we study more than one definition, then we have to study the definition given scientific name also. So in A-level mathematics, this is the first definition in mathematics for a function, right? Then that mathematician says then there are 2 sets, right? There are 2 sets. He named this first set capital X. He named second set capital Y. Right? In relations we mention this is first set, this is second set. Then definition of a function, first set name as capital X, second set name as capital Y. Now there are elements in this set. These are real numbers, right? Then second set also there are elements, no? These are also real numbers, right? These are real numbers. Then he says then each element of capital X set, each element, right? Each element of capital set related to capital Y element, right? With a unique mathematical operation, right? Unique mathematical operation. Then from X set to Y set there is a function, right? There is a function. That means X set each element, that means this element, every element of X set should connected with Y set element, right? But it should be unique, right? It should be unique. The meaning of unique, as an example, if this element is connected with this one, we have to mark it this way, no? Then unique relation mean this element is connected with only YZ one element, right? Okay. Then from this element there should be only one arrow, right? Then this element is connected with YZ only one element, right? This element also same, this element also same, this one also same, right? This is called function. Then we have to notation, there are few notation, right? One is, now we have to express, there is a function from capital X set to capital Y set, right? There are two methods we can express this one. First one is this way. Actually this is not F, right? This is a Greek letter, right? This is right this way, right? But in A-level mathematics, for that letter we just write simple F, right? First we have to put this function name first letter and we have to put two dots. Then we have to write the first set name, capital X. Then you have to put here arrow like this arrow. Then we have to put here second set. This is the first notation. Then there are other notation also. It is this way. We have to put arrow from capital X to capital Y, right? Then function notation we have to write above that arrow, right? This is also expression for function, right? Then meaning of this one, from capital X to capital Y, there is a function, but is that function F, right? This is common, right? If you want other letter also, we can use simple G, simple H like that, right? The original definition here simple F, right? Then second one, there is a name, it is called domain. Domain of function F, this is the notation, right? You have to write first letter of this name D, then just in front of and just below you have to write the function first letter. Then what is the definition of domain, the symbol of domain df. Then he says that what is domain? Domain mean capital X set, right? Then this set is named as domain, right? Otherwise first set is domain, right? Then there is another term, it is called codomain. Codomain. We have to write it this way, capital C, simple O, D, F, C, O, D, F. Then codomain mean, codomain of function mean second set, that mean capital Y, right? Then first set called domain, second set called codomain, right? Is it clear? Domain and codomain, right? Then fourth one, There is another term, it is called image. It is called image. Right? Image mean, if we take this element, right, as an example, if we take this element simple x, then this element related element mean this one. No? If we take this element y, right, then under this function f, image of x is y, right? Then you have to get an idea what is image, what is the image. Image, meaning of image, first set any element corresponding to second set element is called as this element's image, right? Okay, then image of x is y, right? Image of x is y. Now there are a systematic method to write this one. Image of x, right? We can write this say image of x. We have to write function notation, then brackets, then we have to write the element, right? Fx mean what is, then what is the meaning of fx? This is the first set element. Under function f, this element related second set element is the image of x, right? Now we can write fx is equal to y, no? This element image y, right? So we have to write image of x. How we can write that one? Image of x, fx, no? Then fx mean y. Okay. This is the another mathematical term here, image. Now by looking second set, we can say this element is image. No, why? There is a arrow to this element. This is image. This is image. This one image. This one image. This one image. But is this element image? No. This is not image, right? Then there is another mathematical term. It is called range. It is called range. Range of function f, this is the notation, Rf. Then the meaning of range, if we create a set, that set's elements are all the image of this function, right? Then this one element, no? This should be element, this should be element, this should be element, this should be element. Is this an element of range? No. Why? This is not image. Okay. If I put here mark this near this element, I mark here images. So range mean we have to make a set. As an element, we have to take all the images. There are 5 images now. Then as a elements, there should be that 5 image. This is called range. Right. Sixth one. independent variable. Independent variable. Then first we have to know what is variable. What is variable? Variable means it is always changed. No? That means time to time, if there is something, it is changed time to time, it is a variable. Right? Okay. As an example, room temperature, no? It is changing, right? Then humidity, right? Wind direction, right? Like that, there are more examples. What is variable, right? Independent variable mean, right? There is a variable. That means it is changed. But independent variable mean it is variable and time to time it take values of domain. Right? There is a variable, and one time it is this one, next time this one, next time this one, then this one, then this one, right? Again this one, like that. There is a variable, that variable change it times, then as values they can take only elements of capital X. Then it is called independent variable, right? Okay, independent variable. Seventh one, dependent variable. Dependent variable. Dependent variable means there is a variable. It take as its value only images, right? Only images. That means there is a variable, it takes one time this one, then value of 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 this one. Okay, it is changing, but it can't take any value. It can take as its value only images, right? Then it is called dependent variable, right? That is what we have to know under definition of function, right? If this one clear, then that is okay. Again, if we recall this one, then what is the function? The function mean every element of capital X set is related with unique element of Y set, right? Under any mathematical operation, there is a function from capital X to capital Y, right? We can express in this way or this way. Right? Then capital X set, a capital X set is named as domain. Capital Y set is named as codomain, right? Then any element related to first set to second set is called as first set's image, right? This is the image. If we make sets, its elements are only images, then it is called range. It is called range. If there is a variable, that variable takes only values of capital X, then it is called independent variable. And then there is a variable, that variable takes only its value as only images, then it is called dependent variable. Okay. Then here independent variable and dependent variable we define here, because then there is another mathematician, he he gives a definition for a function. He says that if there is a relation between dependent variable and independent variable, it is called as function, right? Okay. Earlier I mentioned that there are 6 mathematicians give 6 definitions for functions, right? Here we study first definition, right? Okay. Now we can write down these topics and then we can go to the examples, right? After that we can do few examples. In that example, when we come to the example, for this element we write real numbers, here also we write real numbers. Then by looking this relation, we can say what is the mathematical operation there, right? Okay. Now write down definition of a function, right? Definition of okay. Stop. Then first write down this before go to the definition of a function, right? Write down this one. Write this a constant. Write down constant. 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 Right. What is constant? Constant mean there is a value. It is not changing with given condition, right? That means if we consider our mass, right? If we consider our mass under short period, no? Okay. Then it is constant, no? Okay. If we take our height for a short period, then it is constant, right? That is the under given condition, right? If we, as an example, if we take mass of a child, it is variable, right? Why? There is no time period, no? But if we consider short time period, right? That means within 1 hour, within 2 hours, like that, right? Then mass of a child is a constant, right? First we have to idea about constant, then we can write down variable, right? Variable mean there is something, it is changing with time. Constant mean it is not changing, right? Okay, write down first constant. Write down this say a value not changing, a value not changing under given conditions, under given condition. Then second topic, variable. Variable. Then write down, it is always changing. It is always changing. Right. Now you know what is constant, what is variable. Now write down definition of a function. Definition of a function. Definition of a function. Right. Now write down this say when each element in a set X, when each element in a set X, right, is related to a unique element of a set y by any relationship such relationships are called functions. Right. Now draw this figure. This is capital X set, this is capital Y set. Okay. Then first one, okay. Then write down first one, function notation. Functions notation. Right. Then write down this one and this one. There are two notations for a function. One is this one, second one is this one. Right. Now second one, write down domain. This is the symbol. Domain. Domain. This is the symbol df. Now write down this say capital X set is named as domain. Capital X set is named as domain. That's all. Now you can write down df is equal capital X. df is equal capital X. Right. Now third one, codomain. Third one, codomain. notation CODF, right? Then write down this way. Capital Y set is called as codomain. Capital Y set is called as codomain. Capital Y set is called as codomain. Then write down CODF equal Y. CODF equal Y. Right. Now both on image. Image. Write down this way. Any element of second set is named as its related first element, its related first set element, its related first set element image. Right. Then we have marked here first set element X, its related second set element Y. Then this is image, right? This is image of first set this element, right? Now write down image of X is Y. Image of simple X is simple Y. Now write down the symbol. Image of simple X, we can write this. Image of simple X, we can write Fx. Okay. So we can write Fx is equal Y. No? Fx is equal Y. Then fifth one, range. Fifth one, range. RF. Then write down this way. If we make a set, all the images as elements, then that set is named as range. Okay. Now write down sixth one. Independent variable. No need write this one, right? Sixth one. Independent variable. Now you can write this way. If any variable always take as its values elements of capital X, right? Elements of capital X, then that variable is called independent variable. Right. Then seventh one, dependent variable. Right. Then write down this way. If any variable always takes as its values elements of range, then that variable is named as dependent variable. Right. Now definition of a function and technical terms of function is so. Now we have to take few examples and we have to check our knowledge about these terms and definition of a function, right? This is the first one. This is capital X set. This is capital Y set. These are the elements -2, -1, 0, 1, 2. These are the elements of set Y. Now, here -2 related to -1, -1 related to 0, 0 related to +1, 1 related to 2, 2 related to 3. This is the function. Now these are the questions. First one, DF. Second one, CODF. Third one, RF. Before RF, F minus 1, F2. Fourth one, RF. Fifth one, simple if. Right. Now, as this is first example, I will discuss, right? Okay, now you can say, what is the first question? DF. Then what is the DF? DF means first statement, that means capital exit. This is the first set. Now we have to write the, as an answer we have to write here, first set, that means capital exit. How we can write capital exit? This is earlier set notation, this one. Right? Now we know how we can write this set. This set elements are integers, no? Integers. So we can write down this set. We have to write each element by separating with comma, no? And minus 2, comma, minus 1, comma, 0, comma, 1, comma, 2. That's all. No? Then this is the DF. When we write DF, these elements, you can interchange these elements. That means no need to write down first minus 2, right? Then minus 1, right? If there is element, if there should be minus 2, right? That is not question about its position, right? You can't write same element again and again, no? Right? These are basic rule of sets, no? If we write minus 2 here, then you can't write again minus 2, right? Then second one, what is the question? CODF, no? Then CODF means set Y, no? This is set Y, so we can write in minus 2, comma, minus 1, comma, 0, comma, 1, comma, 2, comma, 3, comma, 4, no? Minus 2, minus 1, 0, 1, 2, 3, 4. Third one. F minus 1, what is the meaning of this one? Image of minus 1. Then how we can find the image of minus 1? We have to take a set minus 1 element, this one. Now we have to find this element related Y set element. Then we have to, from this element, we have to go through this arrow, no? Then what is that element? 0. Then F minus 1 means 0. Then we have to find F2. The meaning of F2, image of 2. This is the element 2. Then this is the image of this element 3, no? Then fourth one, RF. RF is a set. What is the element of RF? All the images, no? Then minus 1 image, no? 0 is an image. 1 is image. Here 2 is image. 3 is image. That's all, no? This is the range. Fifth one, f mean function. Function mean we have to function mean the mathematical operation, we have to find the mathematical operation, this element related to this element. Right? How this element related to this element. Right? Here 2 is related to 3, no? Then what is the basic logic? This element is greater than 1 than this element. Then immediately we can say we have to add 1, right? But we have to check it. If we add 1 to the 2, 3. If we add 1 for this element, 2, no? If we add 1 for this element, 1. If we add 1 for minus 1, 0. If we add 1 to minus 2, minus 1, it is okay. So what is this? We have to add 1. Addition of 1. Okay. This is the first example. Second one, this is for you, right? Capital X, capital Y. Right. Now, complete first one, right? Then you have to do second example. Right. Then first question DF. The DF mean capital X set now. And we have to write DF is equal minus 2 comma minus 1 comma 0 comma 1. These are the element of capital X set. Then CODF mean set Y. Set Y we can write this way. Elements are minus 1, minus 6, minus 7, minus 4, minus 3, minus 2, minus 5. This is the CODF. Then RF. What is the RF? RF means there is a set. All the elements of RF is images. Then what are the images? Minus 6, minus 7, minus 4 and minus 5. No? Okay, these are the images. Then we have to write function. For that case, we have to check how this element relation with this element in mathematical. Here 0, here minus 5. Okay. So what is the relation? We have to add minus 5. Add minus 5 also correct. Otherwise, subtracting 5. Right? If we subtract 5 from 0, minus 5. No? If we subtract from 1, 5, then minus 4. Subtracting 5, adding minus 5. Both are correct. Then third one. Okay. right? Right. Now first one DF. DF mean capital X set. No? Then elements are -2, -1, 0, 1, 2, 3. Second one CODF. CODF mean set Y. Then elements 9, 8, 4, 7, 0 and 1. Third one F0, that means image of 0. Image of 0 is 0. No? Then F3, F3 means image of 3. This is the element of 3. Then its image is 9. No? Fourth one RF. RF means we have to make a set. Its elements are all the images. Then this is image, no 9. This is image 4. This one image 0. This one image 1. No. These are the image. Fifth one function. Function means mathematical operation. So, by looking -2 and +2 corresponding to one element of set Y, then we have an idea how this can happen. Then we have to take this element's power, that means we have to take this element power, that power should be even number. No? If that power is even, that means power of 2, power of 4, power of 6, power of 8, then minus and positive all comes to the positive, right? Okay. Then here -2 respond to positive 4, no? Then what here mathematical operation? Square, no? Right. This number is square is +4. This one is square +1. This number is square 0. This one is square +1. This one is square +4. This one is square 9. Right. So you have to write down square. right? Now I change this type of examples both on in normally in mathematics functions are written by scientists, right? You also write function in later, right? Then there is it is normal quality, right? It is a quality of scientist, mathematician. If any mathematician write function, then he should write down the domain also, because he is the person know what is that function, no? Okay. Then normally with function always domain is there, right? It should be written with. So that means this type of example. For df equal 0, 1, 2, 3, 4. Then fx is equal, right? To x minus 1. Can you now now can you understand what is this one? Domain is given, no? Then domain given, then what is this one? This is a image of x, no? Image of x. Then what is the meaning of that one? There is two sets, no? Capital X, capital Y. In capital X set, there is element simple x, no? Then this element image is, what is the image of simple x? 2x minus 1. Okay. Now by looking this one, you can write down what is that function, no? What is this function? We have to multiply this one by 2, then we have to subtract 1. Okay. Multiplying 2, then we have to subtract 1. This is the image, right? Now they can ask questions, right? First one, F2. We have to find the image of 2. F4, F2 and F4 you have to find. Then RF. Third one CODF. Simple F also you can question. Now tell me how we can find F2. If you get an idea by looking this one, what is the image of x, then you can directly write down what is the image of 2. No? Then what is the image of 2? How we can find this one? We have to multiply this one by 2. Then what is the value? 4. Then you have to subtract 1. Then 4 minus 1 means 3. You can directly write f2 is equal to 3. Then there is another method. What is that other method? I'll explain it. Find in f4. f4 means image of 4. No? We have to find the image of 4. This is the other method. fx is equal to 2x minus 1. No? If we want f4, what we have to do? We have to substitute for x 4. No? If we substitute for this x 4, then left hand side become f4. No? Then if we substitute here 4, then we have to substitute here also 4. No? Okay. And then you can write down f4 is equal to 2 into 4. 2 into 4 minus 1. Then what is the answer? 8 minus 1 means 7. Okay. Then second one, we have to write RF. To write RF, what we need? All the image. No? Okay. Now, what is the image of 0? We have to multiply this one by 2, then 0. Then we have to subtract 1. Then what is the image? Minus 1. This, what is the image of this one? Multiply by 2, then 2. Then subtract 1. 2 minus 1 means 1. No? Then what is the image of 2? We have find it. No? 3. What is the image of 3? You have to multiply this one by 2, then 6. 6 minus 1 means 5. Then image of 4, we have found it, 7. Okay. This is the RF. Third one, you have to write down CODF. CODF. As you know, RF is always subset of CODF. No? Okay. Because there may be few elements rather than images. No? So, now we know that RF. RF is no. Now we have to write down CODF. Right? Then how we can write? Then definitely this element should be this set. No? Is it okay? Otherwise this can't be subset of CODF. So there should be minus 1, 1, 3, 5, 7. Then there may be few other real numbers. No? Okay. But definitely if we know that numbers we can write here. But we don't know what are the other numbers here. So what we can do? If you write this element and close bracket, this is also correct, right? This set, subset is this one, right? Okay. Otherwise, after writing these elements, then what you can do? You can put any other pure real numbers, that is no problem. But it should, if you minus, put here 0, then 2, right, 9, like that, pure real numbers, and you can close. That is also so. Right. Anyone can't say this is correct, wrong. Okay. Then can we argue this one is correct? It also can't do. Okay. Anyone can't say this is wrong. But we can't argue as this is correct also. Right. For both of they give marks. Right. Both one function, they ask what is function. By looking this one, we can say what is the function. First you have to multiply by 2, then you have to subtract 1. That is the function. Okay. Do this one. Right. Fifth one, now do this. And here df is given and fx is x square plus x plus 1. Now first one you have to find image of minus 2, then range, then codomain.
සියලු දේවල් අතහැරලා වැලියකට ගොන් නාමල් රාජපක්ෂට එරෙහිව
හරි. First one, we have to find the image of minus 2. First method, by understanding this image x That means you have to square, then add it and add positive 1. If we square minus 2, then positive 1, no? Sorry, positive 4. Then you have to add this one, minus 2. Then you have to add 1. No? 4 minus 2 means 2, 2 plus 1, 3. No? Okay. Other method, you have to substitute for x minus 2. Then minus 2 is squared plus minus 2 plus 1. When you simplify this one, then positive 3. Right? Second one, you have to write the range. To write down range, we need every image, no? Then what is the image of minus 2? Positive 3. No? Then you have to find image of minus 1. Right? It is better if you can find that image imaginary. Then minus 1 is squared means positive 1. Here we have to put minus 1. Then positive 1 plus minus 1. Cut it. No? Here this is the remain positive 1. Okay. Then image of 0. Then 0 is squared means 0 plus 0 plus 1. Then 1. We can't write it again. No? We already write 1 there. Then image of 1. 1 is squared mean 1. Here 1. Here 1. 3. We can't write 3 again. No? Then this positive image of positive 2. Then 2 is squared mean 4 plus 2 plus 1. That means 7. No? This is the range. Now we have to write CODF. The best answer is 3, 1, 7. That is enough. Sixth one, fx is equal ax plus b. Here df is equal first one, values of a comma b. Second one, fx. Third one, rf. Fourth one, CODF. Right. Now I change the question type, right? Here what happened here? Domain is given, no? Domain is given. And image of x is given, but there is a problem, no? Image of x is equal to ax plus b. Then what is the problem? There are two unknowns, no? A and b. A and b are unknowns. So we have to find the values of a comma b. Right? There are two unknowns, a comma b, that means a and b constant, right? So we have to find the values of a and b. Okay, now listen to me. Now there is a good mathematical part here, right? If we want to find two unknowns, we have to take two equations, right? Without two equations, we can't find the two unknowns. Right? If there is one unknown, we want one equation. If there are two unknowns, we want two equations, right? That is the logic. Here, now problem is how we can take two equations of a and b. Right? fx given, df given, and there are other two data. No? f1, image of 1 is 5, image of 3 is 9. No? It is given. Now what we can do? This is the way, first one, we are going to find the value of a and b. Right? fx is given, no? Fx is equal ax plus b. Now we know that f1 is equal to 5. Now what we have to do? We have to substitute for x1. Right? We have to substitute for x1. Then we have to substitute here for x1. A into we have to substitute here 1 plus b. Then we know that f1 is 5. No? For f1 we can write down 5. Here a into 1 mean a plus b. This is the equation 1. Then we know that f3. How we can take f3? We have to substitute here for x3. Then we have to substitute here and here for x3. Then f3 is equal a into 3 plus b. No? Then f3 mean 9. No? 9 equal 3a plus b. The second one. Now there are two equations of a and b. We have to solve these two equations. How we can solve this one? Here positive b, here positive b. What we have to do? We have to subtract equation from equation 1, equation 2, from equation 2, equation 1. I subtract from equation 2, equation 1. Then we have to subtract left hand side of equation 2, we have to subtract 5. Then 9 minus 5 means 4. No? Then right hand side from 3a we have to subtract a. 3a minus a means 2a. No? Positive b to positive b remove. Now how we can find the value of a? We have to remove this positive 2, then we have to divide both sides by 2. If we divided 4 by 2, here value of a is 2. Now we can substitute this value of a to equation 1. Then 5 is equal, for a we have to substitute 2 plus b. No? Now we have to take this 2 this side, then 5 minus 2 means 3. This is the value of b. Now we know the values of a and b. And then second question, we have to find the fx. How we can find the fx? The value of a and b, we have to substitute here. Value of a 2, no? We have to substitute here, then 2x. Plus value of b is 3, We have to substitute here. This is the fx, right? Now we know the fx. Now we can find the image of every image. No, by finding image, after finding image, we can write down RF. Then we can write CODF. Right? Finish this one. Now we now we have found the apex now. Now we can write the RF. To write RF, we have to find the image of minus 1. Now we can find the image of minus 1, we have to put here minus 1 now. Then 2 into minus 1 mean minus 2 plus 3 mean plus 1. And then image of 1, we have to put here 1. Then 2 plus 3 mean 5. Then we have to find the image of 2. Then 2 by 2 mean 4. 4 by 4 plus 3 mean 7. No? Then image of 3. Image of 3 is given 9. Then image of 4. 4 into 2 mean 8. 8 plus 3 mean 11. Okay. Now both one CODF. Okay. Then seventh example. DF is minus 2 minus 1 0 1 2. For apex is Right. Now first you have to find the values of A, B, C. Then there are three unknowns. That means we have to take three equations of A, B and C. No? We can take three equations for A and B, A, B and C. We know fx is equal ax squared plus bx plus c. No? Image of minus 1, that means f minus 1 is given. No? So we have to substitute here for x minus 1. Then here f minus 1. A into we have to substitute here minus 1. Okay. Then f minus 1 means 2, no? 2 is equal. Minus 1 squared means positive 1. Positive 1 into A means positive A. Here positive into negative, then sign is minus B plus C. This is the equation 1. Then image of 1, f1 is known. So we have to substitute for x positive 1. Then f1 is equal A into 1 squared plus B into 1 plus C. Then f1 is 6. 1 squared mean 1, 1 into A mean A, B into 1 mean B plus C. This is the equation 2. Then f2 is 11, no? Then we have to substitute for x positive 2. Then f2 is equal to A into 2 squared plus B into 2 plus C. Then f2 mean 11. Here 2 squared mean 4, that means 4A. Here 2B plus C. This is the equation 3. Now, if we consider equation 1 and equation 2, here positive A, here positive A, here positive C, here positive C. If we subtract equation 1 and equation 2, A and C is removed. Then we can take a equation with B, then we can find the value of B. So first I subtract from equation 2 equation 1. Then 6 minus 2 mean 4. No? A minus A remove. B minus minus B. B minus minus B. C minus C remove. No? Then here 4 equal minus into minus mean positive, no? Positive 2B. We have to divide both sides by 2, then value of B is 2. No? Okay. Then from equation 3, I subtract equation 2. Then 11 minus 6 mean 5. No? 4A minus A mean 3A. 2B minus B mean B. Plus C minus C remove. Okay. Now we know the values of B, so we can substitute. Y is equal 3A plus for B we have to substitute 2. Now we have to take this positive 2 this side, then 5 minus 2 mean 3. Now 3 is equal 3A. When we divide that by 3, then value of A is 1. Right? Now we know the values of A and B. Then we can substitute these values for equation 1. Then 2 is equal, for A we have to substitute 1. minus for b we have to substitute 2 plus c. 1 minus 2 mean minus 1, we have to take minus 1 this side. Then 2 plus 1 mean 3 now. Then value of c is 3. These are the values for a, b and c. Now we have to substitute this value here, and then we can find the x. For a we have to substitute 1. For b we have to substitute 2. For c we have to substitute 3. 1 into x squared means x squared plus 2x plus 3. This is the function. This is the image of x now. Image of x. Now we have to find the range. Then we want to find the image of minus 2. Minus 2 is squared positive 4, minus 2 into minus 4, 3. Then image of minus 1, it is given 2. Then image of 0, 3 now. 0 is squared plus 2 into 0 plus 3. We can't write again 3 because already we have written 3 there. Then image of 1, it is given 6. Then image of 2, it is also given 11. This is the RF. Then fourth one, CODF. This is the CODF. Right. This is another type. Right. Now in this case you have to very carefully because here domain is given, no? But this domain is given as an interval notation. Right. This is also said but this is continuous set, right? Minus 3 comma 4, both side normal brackets. That means domain is in domain elements are all the values in between minus 3 and positive 4. Right? That means there is infinite number of elements, right? Minus 3 to positive 4. Then image of x is 2x plus 3. Image of x. Now we have to find the range and see codomain. To find the range, we have to find all the image. No, we have to find all the image. As there are infinite number of elements, it is not possible to find each image. No. Okay. Now here we have to use a special trick, right? Then what is x? X is any element in domain, no? X is any element in domain. The meaning of that, x can take any value in between minus 3 to positive 4. No? So we can write here double integration for x. What is that double inequality? What is the double inequality? We can write x is less than 4 and greater than minus 3. Is it correct? Why? Simple x is element of this set. No? Then we know element of this set is in between minus 3 and positive 4 any value. So we can write x is greater than minus 3, less than positive 4. Is it okay? Then we have to find all the image. No? Then images are 2x plus 3. No? Images are 2x plus 3. Now we have to make here in between two inequality marks 2x plus 3. That is the way. Okay. Then first we have to multiply x by positive 2. Then we have to multiply this in double inequality by positive 2. Then here positive 2 into minus 3 means minus 6. Here positive 2 into x. Here 2 into 4 means 8. As we multiply positive number, inequality mark not change. No? Then now 2x is there. Now what we have to do? We have to add 3. No? Now we have to add 3 for all the sides. Then here minus 6 plus 3. Here 2x plus 3. Here 8 plus 3. Minus 6 plus 3 means minus 3. Okay. 2x plus 3 means fx. Is it okay? 8 plus 3 means 11. Then what is the meaning of this one? If x lies in between minus 3 and positive 4, then image of x lies minus 3 and positive 11 in between those two values. Right? So now we can write by looking this one range. Okay. So we can write range minus 3 comma 11. We have to put here normal bracket. Why we put here normal bracket? Minus 3 is not in range, no, because here there are no equal mark. Then 11 is not not a image, because here is also not equal mark. But in between minus 3 to 11, any values are image. So this is the RF, right? Wait. If this one RF, we can write CODF. How? How we can write CODF? Write down this one itself, that one also okay. As we know, we can put any values rather than this one for CODF. If we put this interval as a additional value 11, then what happen? 11 is there, no? Then now we can write this interval. Minus 3 comma 11, minus 3 not include, but 11 include. Then here should be square bracket. No? Another way, we can add here minus 3, then minus 3 comma 11, minus 3 include, then 11 not include. Right. Another way, we can add both this set, two values. What is that value? Minus 3 and 11. Then minus 3 and 11 also elements. So then now we can write this set. Minus 3 comma 11, here should be square bracket, here also square bracket. There is another way. What is that way? We can put here all the values 11 and greater than 11, and other one minus 3 and less than minus 3, all the values. Then what is that set? In between minus infinity to positive infinity, right? So you can write it as minus infinity comma positive infinity. Then you can write this one, another easy method, capital R, and you have to double this line. This is the notation for real number set, right? Any answer should accept as CODF. Okay, write down this. Right. Ninth one, DF is equal This is the domain. Then fx is x minus 3. Now you have to find RF and CODF. Right. Then what is the special this question number 8 and 9? Earlier we discussed every example, domain is a finite number of elements. Then what happened equation, example 8 and 9? In domain there are infinite number of elements, right? So we can't by substituting find the images now. Then what we have to do? We have to write inequality, and by using that inequality we have to take all the images, right? Right. Now simple x is element of df. No? Then what we can write? Simple x is greater than minus 2, less than positive 3, and equal positive 3. No? So we can write here x is greater than minus 2 and less than positive 3 and equal to positive 3. This is the inequality for x. Then image mean x minus 3. No? Now we have to create in between two inequality marks x minus 3. How we can do it? First we have to multiply this inequality by positive 4. Then here minus 2 into positive 4 means minus 8. Here positive 4 x. Positive 4 into positive 3 means positive 12. Now we have to subtract 3. No? Then we have to subtract 3 all the sides. Then minus 8 we have to subtract 3. x we have to subtract 3. Here 12 we have to subtract 3. No? Simplifying these two, minus 11. x minus 3 mean fx. No? 12 minus 3 mean 9. No? This is the inequality for images. Now we can write down the range. Minus 11 comma positive 9. Minus 11 not include, so normal bracket. Positive 9 include, no? So near 9 should be square bracket, right? This is the range. Then how we can write CODF? If you write this one, it is okay. Otherwise, you can put additionally minus 11 and we can put both side square bracket. That one also okay. Otherwise, you can put all the values other than this element, then we can write down as a real number set. That is okay. That one also okay, right? Then example number 10. Here df is minus 3 comma 4, both side square brackets. For this case, fx is equal to 3 minus 2x. 3 minus 2x. Now you have to find RF and CODF. Right? In this case, you have to give special attention because you have to multiply x by minus 2, right? What happened when you multiply any inequality by minus value? Then inequality mark should be changed, right? Here image of x is fx 3 minus 2x now. Then x is element of this set. What are the elements of this set? Minus 3, positive 4 and in between minus 3 to positive 4 any value. No? So we can write the inequality for x. X is greater than minus 3 and less than positive 4 and equal to minus 3 and equal to positive 4. Okay. Now we have to make in between inequality marks 3 minus 2x now. Then first we have to multiply this inequality by minus 2. Then minus 2 into minus 3 mean positive 6. Then inequality mark reverse now. Minus 2 into x mean minus 2. Here minus 2 into positive 4 mean minus 8. This inequality mark reverse. Right. Now we have to add positive 3 for each and every side. Right? Then we have to add this side 3. Then 6 plus 3. Here we have to add 3. Then 3 minus 2x. Here we have to add 3. Here 9. 3 minus 2x mean fx. Minus 8 plus 3 mean minus 5. This is the fx. That meaning of this one, image just can take minus 5, positive 9 and in between minus 5 to positive 9 any value. So we can write range RF. We have to write first small value minus 5 after comma large value 9. As minus 5 include, we have to put here square bracket. As 9 also include, we have to put here also square bracket, right? So this is the range of function. Second one, CODF. No? Then CODF mean you can write down this one itself, it is this one also correct. So if we put any values additional to this one, then don't put 1 or 2 values, right? Then you have to put greater than 9 all the values and less than minus 5 all the values. Then you can write this is real number set. Okay. Okay. Then up to this one, first we define what is relation. Then we discuss there are two relations, one to one relation and many to one relation. After that we discuss definition of a function. Then the notation for function, then domain, codomain, image, range, independent variable and dependent variable. After that we discuss 10 examples. In this 10 example, we use various methods to find RF, CODF, image and like that. Right. After that we have to study graph of a function. Right. What is the meaning of graph of a function? Right. Then after that we have to study 6 types of graphs. Sorry, 6 types of functions we have to study. Then each type of function we have to draw graph of that function also, right? Graph of that function also. Right? Then next class we can finish. Yes. We can finish 1, 2, 3, 6. Nearly 4 types of function and its graph. Then then after that we have to discuss there are another 2 graphs. Then this lesson is over.